Today we're doing 3.4. We're going to factor it first. So it's going to be given to you either not completely factored or not factored at all. And we're going to factor it and then sketch the graph. And this will be good to help us review for this quiz everything that we're going to need for that. Before we get to it, there's a couple where they do this function notation. And I would like for you guys to get these in the notes. We've kind of been doing this just as it's come up on the homework, but I want this in your notes now. Okay? Where you have to do something first to create the function that we're going to graph. For example, if I told you that f of x was 2x, and I told you that g of x was 3x squared plus 5, and I asked you to find this, and this is the way it's going to be notated. It's kind of a funny notation, but we have seen this, where they do f, and if this is solid, that means times. Okay, that right there means take f of x and multiply it by g of x. It's just it's a math shorthand, but it means this. Take the function f of x and multiply it by the function g of x. Okay, so that just means take your 2x and multiply it to 3x squared plus 5. At this point, if you were going to sketch this, now we're not going to sketch this particular one, but if we were, I would ask myself, do I want to distribute that? I may not want to, because it might be that that's all nicely factored. Okay, but if there was any other way I could factor it, I'd want to do that. In this case, if I would go ahead and multiply that out, so 6x cubed plus 10x is what that would equal, and maybe that would be better, and then go back to factoring from there. Okay, just depends. All right, let's try another one of these. What if it said this? F minus g of x is how you read that. F minus g of x means take f of x and subtract g of x. Be careful when you're subtracting, you guys. When you're subtracting, you've got to make sure you're subtracting the entire quantity g of x. So I would suggest that you put that minus sign and then you put g of x in parentheses and then distribute that negative. Okay? So f of x is, it's same f of x, it's 2x minus g of x is 3x squared plus 5. Can you see how it'd be really easy to make the mistake and just say it's 2x minus 3x squared and then plus 5? When it should be 2x minus 3x squared minus 5. You got to distribute this negative in front here to both. You have to subtract the entire quantity. If you end up just minus 3x squared and then plus 5, you haven't subtracted the whole thing. You added the 5, you didn't subtract it. So basically, when you're subtracting, whatever you're subtracting, you need to change the signs of it. If it was, these were both positive, they both became negative. If they were both negative originally, they'd actually both become positive. You switch the signs. Okay, so let's try it with two different functions. What if f of x is x plus 1 and g of x is negative 2x squared minus 4? And I asked you to subtract, okay, and asked you to do f minus g of x. You can write that separately if you want, f of x minus g of x, but you don't have to. If you recognize that's just subtracting the two. Some of you were doing kind of some funny things on the last test. You subtracted, and that's like you multiplied it by x. This isn't saying multiply it by x. This is a notation that's saying it's f of x minus g of x. Okay, so again, you take, this is what it means, f of x minus g of x. You're not multiplying those by x. It's telling you what letter you're subtracting those with respect to. Okay, f of x is x plus 1. I don't have to worry about the first one. That's no problem. It's what I'm subtracting. That negative 2x squared minus 4, I need to distribute that negative to both. Okay, so this would become x plus 1, and then what you'll notice is that both signs changed. Since these were both negative, they both became positive. Okay, so whatever you're subtracting. And then combine like terms, and we'll put it in descending order. So it'd be 2x squared plus x plus 5. And then from there, we will attempt to factor that and sketch it. We're not going to do that right now. I just wanted to review that notation. Okay, so if this is a plus, same thing. If this was division, you do it the same way. Not going to have any division yet. That'll be later. Okay. So today you're going to be factoring, and so I want to review a little factoring, and then we're going to go to sketching them. Okay? So directions for these first ones. First examples here, I want you to factor completely. Part of why we did the little factor review yesterday, for you guys that were taking the PSAT and those that were here, we all did it, just that little factor review. They're going to be kicked up a degree or two. So for example, if I had x to the 4th minus 8x squared plus 12, if you have 3 terms and they don't have a GCF, the next thing I would look at is this power double this power? If it is, you actually want to factor it like this. And the 2 terms that would multiply together to give you x to the 4th, if this is x squared, they'd have to be x squared. Have you done this type of factoring before? Where these are both x squared? Anybody seen that before? Okay, so this is new. Do you see that if I multiplied x squared and x squared, I'd get x to the 4th? Then you do it just like we did the other ones. What are 2 factors that multiply to give you 12 and add to give you negative 8? Negative 6 and negative 2. Okay? At that point, if these were perfect squares, you could factor it more. But since 6 and 2 aren't perfect squares, we'll just leave it like that. Okay? Let's do one where those end up being perfect squares. X to the 4th minus 24x squared minus 25. Okay? So I'm going to set this up. There's no GCF for those 3 terms. I'd look for that first, but there isn't. And so I'm going to set it up this way. And I know these 2 have to be x squared. That's how I could get this middle term being x squared. Okay, now we're trying to find 2 factors that multiply, 2 factors of negative 25 that add to negative 24. Negative 25 and positive 1. Okay, now the one that's subtraction, you can factor more. X squared minus 25, the difference of 2 squares, dots, can be factored into x plus 5, x minus 5. But this one, you guys, this one can't. We can't factor the sum of 2 squares. So we'll just leave it like that. That would be your answer if you're factoring it completely. All right, one more factor example. Factor this, negative 3x cubed plus 12x. Just 2 terms. I always look for GCF first, and this has it, right? What could I pull out of both of those? A 3x. I also could pull a negative 3x. I'm going to pull the negative out also, okay? So if I pull a negative 3x out, what would be left here? If I divided this by negative 3x, what would be left? X squared. And then if I pulled a negative 3x out of positive 12x, what would that leave me? Minus 4. That can be factored more, right? That's dots. This is the difference of 2 squares, which is x plus 2, x minus 2, and that would be your answer. Okay? Second type of problem that they're going to ask you to do, they're going to ask you to find the zeros. In parentheses, I want you to put roots. Same thing. Find the zeros and the roots. And you do the exact same thing to find the x-intercepts. Okay? So find the zeros or the roots. So let's put in parentheses x-intercepts. And I want you to also state their multiplicity. Okay? Give me the multiplicity. Can we do it for the problem that we just did? This problem that we just had, we'll call it number 4, but it was negative 3x times x plus 2 times x minus 2. The zeros mean set that whole function equal to 0. If I set this equal to 0, we'd go through and we'd set each part equal to 0, right? Could I set negative 3x equal to 0? Would that give me is that a nonsense answer, or does that give me an answer? It gives me an answer, right? Negative 3x equals 0 happens when x equals 0, right? I could divide by negative 3. So that's 1. So my zeros are 0. If I set x plus 2 equal to 0, what does that give me? We've done this enough, right? Same as the x-intercepts. What's that give me? negative 2, right? It's the opposite. Subtract it over. And then this one, positive 2. What's their multiplicity? It's what's the power on all of these first. So we'll just say multiplicity 1. We good? Turn the page. Okay, how about this one? X to the 4th minus 36x squared equals 0. X to the 4th minus 36x squared equals 0. To find these zeros, I need to factor it. What could I do to factor this? Do what? Take out an x squared. What would be left? Okay. Can I factor that anymore? Can I factor this, x squared minus 36? Yeah, all right. How can I factor it? Plus 6 and minus 6, right? Okay, so now can you see the zeros? X squared equals 0. I could set that equal to 0, right? What would I get? 0. Okay, so one of the zeros, yeah, or the roots, is 0. What's its multiplicity? 2, right? Because it's squared. So when I graph it, what's it going to do? It's going to bounce, yeah. And then I'd have a positive 6 and a negative 6, which I'm going to combine to plus or minus 6. Both of those would be zeros, right? And they have a multiplicity of 1, which again, some would say we don't really need to say that, but they would then both cross when we graph them. Okay, now getting to actually sketching. So the directions for the last couple examples here: factor it, then sketch. And it's going to say label the x and the y intercepts. So let's just say label intercepts. I would say if we lose little, points that would be easy to get, it's because we forget to label. Okay, so just watch out for that when you're doing this quiz today. Okay, so number 1, f of x equals you ready? F of x equals 4x to the 4th minus 64x squared. You guys, since we're going to be sketching this, this is the easiest place to determine the end behavior. And these are the first couple questions on this quiz. What's going to be the end behavior of this graph? What do you look at? The biggest power is 4, and it's positive, so it's going to go high, high. So I'm going to note that right here. My end behavior, I'm going to remember that. It's high, high. Okay? And then to sketch it, though, I need the x-intercept, so I need to factor it. GCF of 4x squared is what I could pull out. If I pull a 4x squared out of this, I'd have x squared remaining. Do you know how many times 4 goes into 64? 16, right? And then I can factor that even more to x plus 4, x minus 4. And from this, I can see my x-intercepts, and I can tell whether they're going to bounce across, right? So your x-intercepts, your roots, same. You find those the same way. The first one's going to be 0 because of this x squared, right? So set that equal. And what's it going to do? Bounce or cross? It's going to bounce, right? Even bounces, odd crosses. And then I'd have the plus or minus 4 from this negative, the x plus 4 and the x minus 4, both of those. And they're both going to cross. We good with the crossing and the bouncing? Okay. To find the y-intercept, you can either in the factored form or the non-factored form plug in 0 for x. You guys, it's actually easiest if you go back up before you factor it. Plug in 0 for x. If you plug in 0 and 0, what's it going to equal? 0 minus 0, 0, right? Your y-intercept is going to be 0 also. Okay? That's the easiest place to look. Or you could plug it into the factored form, but I feel like up above is a lot easier. All right, let's graph this. We need an x-intercept at 0, so set up x and a y-axis, plot 0, and then plot negative 4 and positive 4. Okay, then we said it should cross at -4 and +4, and it should bounce at 0, and it should start high and end high. So I'm going to start high, I'm going to cross, I'm going to turn around here, not make a sharp turn in, make a nice smooth rounded curve, and then cross again. Start high, end high. I've labeled everything, and I'm good. Then it's going to ask you a series of questions. How many x-intercepts does that have? That's not too difficult. This has 3 x-intercepts. 3 x-intercepts. And then it's going to ask how many relative max and how many relative min. How many relative max does that have? Just one right here, right? One relative max, the place where it changes from increasing to decreasing, right? How many relative min? 2. 2 relative min, right? These 2 right here. Scale of 1 to 4. We would do another problem just like that if you need to. Can you tell me where you're at? 1, I have this. I don't need to see another problem. 4, I don't have it. I definitely would like to see another problem. Can you tell me where you're at, please? Awesome.